Okay, we're going to talk about how we can graph using the slope y-intercept. I was alluding to this earlier, but I'm just going to make it a little bit more explicit. So the idea here, and what's nice about these two graphs is they're already set up. That could be convenient. It might not be convenient for graphing all lines, right? Because maybe you don't want to use a scale of 1. But I like that this has the x and the y axis, and it has a scale already drawn on here. Now, of course, you can always do a table of values, and you could do a table even horizontally. So the table I showed before was vertical, but maybe you do x, y this way. So the easiest point to plot, we said, was the? 0. Yes, the 0, the y-intercept. We call that the y-intercept, and we have it right here. If you plug in 0, what do you get? 0, -2. Okay, so 0, -2 is here. And then from there, how would I get some other points? Could I use the idea of the slope? So m, we said before, is the slope. That's 2/3. And that's the rise over the run. And if you were going to do your table, I would suggest, yes, you do multiples of 3. So you might do -3, -6, 3, 6, 9 maybe. But we're going to actually, instead of having to plug those numbers in and do the math that way, we can use what's called the slope. We can use the rise over the run. So if we know that our rise is 2, that means I go up 2, 1, 2, and I run 3, 1, 2, 3. So there's my next point, and that happens to be an x-intercept. So that means if you had plugged in 3, you should get 0, right? From there, I could go down 2, 1, 2, and run backwards 1, 2, 3. Where am I getting that idea of negative, negative? Well, that's because any fraction, if you have a fraction that's positive, if you have -2 over -3, what's a negative divided by a negative? A positive. So that's why I could go down 2, back 3, and once I have my 3 points, I can go ahead and draw the line. Now, of course, you can always do the table of values if you forget how to do this. And then if you had multiple lines, you might even write next to the line, y equals 2/3 x minus 2. So it could be good to just label the line. And I was labeling the points earlier. You could do that as well. But if you had plugged in -3 for x, you should have gotten, hopefully, -4. Right, so that would be the idea of using a table or using the slope y-intercept. So let's look at this one. What's the y-intercept here? +2. So 0, 2. And then what's the slope? You could say it's -1 over +3 or +1 over -3 because we're going to want to go up and down. Now notice a positive slope is increasing from left to right. A negative slope is going to do the opposite. It's actually going to decrease from left to right. So that's because from here, from my y-intercept of 0, 2, I can go rise -1, run 1, 2, 3, +3. Or rise +1, run -3, 1, 2, 3. And my line will go down from left to right because I have a negative slope. Because a lot of times people will say, well, where do I have to put that negative sign on the fraction? And the truth is, when you have a negative fraction, either the numerator was negative or the denominator was negative, but not both. Okay? Now, the reason why on example 5, which many of you started practicing this one, that's really great, there is no scale drawn here. And that's because here you have a slope. What's a slope here? Yeah, and so maybe you don't want to use a scale of 1. You don't have to. You could use a scale of 1 or you could change the scale. So if I were to draw, here's my x-axis, and then my y-axis, there's a couple of different ways you could think about this slope. So this is actually the same thing as -0.2 over 1, or it could be y equals, does anybody know what the fraction is that's equal to? Yeah, or -1/5. Yeah, -1/5 is the same thing, plus 1. Okay, so here, if I wanted to use the different scale, if I wanted to change my scale, maybe I wanted to use a scale of 0.2 so that I could really just go up and down 0.2 and my rise would be 0.2. So if I did that, I could go 1, 2, 3, 4, 5 and call that 1. 1, 2, 3, 4, 5. Down here would be negative 1. Do you see why I'm doing that? I'm actually using a scale of what? 0.2. 0.2. Because I'm counting by fives, and 1/5 is the same thing as 0.2. And then what's my y-intercept? It's 0, 1. So I could start there. And then from there, if I wanted to use the scale, and I'm going to count here 1, 2, 3, 4, 5. Can I use a different scale on my y-axis as my x-axis? Yeah, absolutely. -2, -3, -4, -5, -6. I could have even skip counted. That gets kind of crowded, so if I skip counted, but here maybe I'm saying this is 0.2, 0.4, 0.6, 0.8, and then 1 whole. So if I'm going to go down 0.2, remember that -0.2 is my rise, and 1 would be my run. So I'm going to go down 0.2 for every 1, down 0.2 for every 1, down 0.2, 1, 0.2, 1, 0.2, 1, and then this would be what my graph could look like. And of course you could also do a table of values for this as well. If you wanted to know if this is correct, like let's say you weren't sure that you did it right. What is this point, this ordered pair right here on the x-axis? Can anyone tell me the ordered pair? 5, 0. Good. And you didn't mix it up because sometimes we get the x and y mixed up. But we went over 5, down 0. I could call that a checkpoint. If I wasn't sure if I graphed the equation correctly, I could take any point on the line. And it doesn't have to be this point. I just happen to like it because it has whole numbers, and it also has 0, and 0 is super easy to work with. If I were to plug this point in, I could check and see, does that point satisfy the equation? And that would be like counting as a check to make sure, because a lot of times what happens with graphing is we can graph, we don't have a way of knowing did I graph it correctly unless I look on Desmos. So if I plug this point in, I plug in 0 for y, and I plug in 5 for x. Does that work out? In other words, is this line correct? So what would this be right here? This should be -1, 0 equals -1 plus 1, 0 equals 0. So my checkpoint is just a way for me, and I'm mentioning the checkpoint now because I am going to give you a quiz later, and I am going to ask you to do a checkpoint. And most of the students forget to do the checkpoint. But you want to know, is my equation graphed correctly? So pick any point on the line, plug it in, and now you've checked. If that point satisfies the line, and you already know this point does, then you can feel pretty confident that the rest of the points on your line are correct as well. Does that make sense? All right. Any other questions about graphing lines here?